Hi guys, today we'll be covering Principles of Flight for the RAF Part 1 exam. We'll cover things like Newton's third law of motion, lift and weight, wind tunnels and Bernoulli's principles, and the parts of a wing. Newton's third law of motion states that to every action there is an equal and opposite reaction. We know that if the weight of a car pushes down on a road with 1 ton, the road has to push back with the equivalent force of a ton. The same applies to a boat on water. If a boat pushes on the water with the force of 10 tons, the water must push back with a force of 10 tons. Now, how does this apply to a plane which is supported by air? Let's say you hold a relatively heavy object like a snow globe in one hand and you hold it at arm's length. You can feel the force of the snow globe pushing down on your arm, and your arm pushing back up to resist the force of gravity. Now, how does this apply to an aircraft? We can try a little experiment here. If you get two A4 sheets of paper, hold them together with one finger, creating a gap in between. Blow into them and see what happens. Surely the paper should be blown apart, right? The opposite effect happens. The harder you blow, the more firmly the papers are drawn together. Similar effects can be seen in everyday life. A slightly open door closing rather than opening when a breeze blows through the gap. What causes these things to happen? To find out, we use a wind tunnel to experiment. In this simple experiment, air is blown into the tunnel at A, passes through B, and comes out at point C. The speed and the pressure of the air is measured at each point. Now, as point B cannot hold any air, the same amount of air going into B must be the same amount of air coming out. Therefore, in order to have the same amount of air coming through B as there is coming out, despite there being less space for air to actually go through, airflow must speed up, going from A to B and slow down from B to C. If the air is speeding up, this creates a low pressure area, and if the air is slowing down, a high pressure area is formed. This effect of wind speed on pressure is known as Bernoulli's principle, and this is the main point you want to take away from this experiment, as it's what they ask you in the paper. This should be able to explain your experiment earlier with the two sheets of paper. When you blow between the papers, the speed of the air between the sheets causes pressure to drop, which allows the pressure on the outside to push the sheets together. Bernoulli's principle is also true for all fluids, so the same applies in water. Now, you can prove it again yourself by following the experiment on the screen. I'll keep it up for a few seconds so you can read it and try it out. Now you can see here that the top half of a wing simulates a wind tunnel's constriction, just like your pieces of paper. This means that the air flows over the wing faster than it does below it, creating a low pressure area over the wing for it to be lifted up into. In reality, the airflow will not approach the wing like this. The wings are usually tilted down a little bit so that the airflow is redirected, providing a tiny bit more lift in flight. This effect is known as downwash, and while it's not as strong as the lift from the low pressure area at the top half of the wing, it does assist in holding the aircraft up in flight. Here are some more points about the lift on the wing. These 5 points come up a lot in Part 1 papers, so it'd be a good idea to try and learn these. First of all, lift is not distributed evenly around the whole wing. You can see here that the arrows from about a third of the way down from the top of the wing are the greatest. This shows that lift occurs the most at these areas. Another thing to note is that all lift forces act at 90 degrees to the direction of airflow. Here are a few things that can affect the lift. Airspeed. Changing the airspeed will vary the amount of lift produced by the wings. When an aircraft is stationary or it's not moving, the wings are producing no lift. However, as an aircraft accelerates, the lift increases, until there is enough for the aircraft to be lifted off the ground. Double the airspeed gives 4 times the lift, triple the airspeed gives 9 times lift, and so on. B. The angle of attack. As a pilot lifts the pitch altitude on the aircraft by easing back on the controls, the angle of attack will increase. Now, the amount of lift will increase with the angle of attack up until about 15 degrees. If the angle of attack has increased beyond here, the lift rapidly decreases and the wing will start to stall. Air density. If the air is thinner or less dense, the amount of lift is reduced. Vice versa, if the air is denser or thicker, the lift is increased. And finally, wing shape and area. These 6 different shapes will provide an aircraft different speeds, different types of lift, and so on. These aren't too important to know, but it'd be nice if you did learn them. Overall, all of these factors come together to increase an aircraft's lift. If an aircraft's lift is greater than its weight, it will ascend. If an aircraft's lift is equal to its weight, it will just stay where it is, stationary in the air or on the ground. If an aircraft's lift is lower than its weight, then it will start to descend. Now here's a little quiz for you to review what you've learned in this presentation. I'll leave the answers on in the next slide, and we hope you enjoyed it.